What's up, fellas? It's Mark here with Wheels and Wrenches, and I'm working on my 14 bolt. I'm planning a trip October 9th and 10th to Windrock, Tennessee to go to the Bleep and Jeep fan ride, and there was a couple little small issues I'm addressing. I talked about in an earlier video about the ceramic pads on the front of my Dana 60, and we were trying to eliminate the squeaking problems, and that worked, thankfully. And the back's still squealing, so I have the entire 14 bolt pulled out right now. Everything's disconnected, and I'm going to address an issue with the 13 bolt cover that most people have, and it can kind of be a big problem if you don't address it and take care of it properly. So I'm going to go over that, and I'm probably going to do the ceramic pads in the rear to get rid of the squealing. I tested the vehicle out at Wellsville last weekend with Erie Shores Jeepers, and the front end didn't squeal. The rear end still squealed. So I'm going to check the alignment on the brackets. The weld-on brackets on the axle tubing need to be at the same exact angle as the rotor. And I got to check those, and I'm going to put on the ceramic pads, which happen to be the exact same ceramic pads that I used on the front, so that's a good thing. And I'm going to go over some technical stuff about this 14 bolt shave slash 13 bolt cover, the differences, and what you can do when you do your 13 bolt cover to make everything work better and not have any cracking issues. It could be a big deal if your bottom of your housing is too thin and you hit a big boulder and it cracks. That's not good. So we're gonna go over that, how to fix that problem so it will never happen, and also how to address the sealing issues when you do the 13 bolt and you weld on the bottom. The diff cover won't seal oftentimes. So we're gonna fix that, and then we're going to talk about the reinforcement plating and how to weld it, and the preheat and the rod being used and all that fun stuff. So stay tuned. Thanks for watching. Bye. Okay guys, here's the mighty 14 bolt in my mighty messy garage. Got her pulled. Oh, that light's bright. Got her pulled. Links are tied up, hanging, shocks are hanging, calipers are hanging. Got the brake pads out, and figured out they are the same as the fronts. And we're gonna talk about this axle here for a second. So this is what you get. There is a bolt that is in this general vicinity that actually it's probably about right here. So when you do your 13 bolt cover, you bolt the cover onto the diff. You take a marker and you trace the edge of the cover, and then you grind the housing down. You grind the housing down, ignore that dotted line for now. You grind the housing down until you get to where the new housing is ground flush with the new 13 bolt cover. And that's what you do. And it's not a hard process, but it's a messy process because you have to grind a bunch, and you need to obviously you're gonna have grinding dust everywhere, and probably wouldn't be a bad idea to wear a respirator and a face shield, you know, and all that good stuff. But the issue, and this is the main issue, is this surface right here. Mine's beefed up, so if you think that's thin now, that's with weld, special nickel welding rod added on. So it's beefed up, I'd say 1/8 of an inch thicker than it was originally. What happened to me is I was wheeling, I believe I was at Doe Valley in Pennsylvania, and I cracked the housing right here. It was about a 2-inch crack. It went all the way through, and I was a little bit panicked. So what I did was I gouged out the crack. I drilled the end of the crack to stop it with a small drill bit, and then I grooved the crack out with a 1/4 inch grinding disc, and then I welded it back up. I back welded the inside and I welded the outside, and then I used a tiger paw to smooth everything out. So now what you're looking at is that, but this lip here, this sealing surface between these two bolts, it has to be perfectly smooth, and it has to be true to all the rest of the ceiling face. So once you weld, and you have to weld all the way to this edge, what you do is you have to go back and completely resurface that area, or else you're going to be left with a very, very thin spot, about 4 inches wide right here, and it is going to crack 100%. As soon as you smash it off a rock, it's going to crack. It is what it is, but it has to be addressed, and that's what this video is for. I'm going to show you guys how to do that. So here we go. All right, guys, once this is welded and you're building this surface up where my file is right here, you're building this surface up on the outside here. The casing should be preheated with a MAP gas torch, an acetylene torch. You're not ever going to use oxygen and acetylene on something like that. I guess you could, but it's not necessary. So a small handheld MAP gas torch. Heat up this whole top of this housing to 400 degrees, and then start laying beads across the top, 50-50. That means they're not side by side, each bead is overlapping each other by half of the bead. So bead, 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 and you're building this section up. Okay, that's step one. Then step two is truing this surface up, and this is a tedious, labor-intensive process. You're gonna file this, and you're gonna stay on the same plane as the rest of this down here. This is your guide. These sides are your guides, because this hasn't been messed with. So you're gonna use this file. File's one direction. You don't go back and forth with a file. You go one direction, file, and you smooth this out, and you get this ceiling surface as true as humanly possible, and you get it as close as you can with the file. And then you take this is the secret weapon here. This is a chunk of it might even be 1.5 inches. It's an 1.5 inch steel bar. It's like a billet piece of steel, and I've wrapped sandpaper around the sides, and I've taped it. Now this is what gets it really true. You put that against it, and you're here, and you're working it back and forth like this, coming over here, back and forth. It may take a half hour, it may take 45 minutes of doing that until it's sealed. Then you get a straight edge, and you run your straight edge across from here to here, and you make sure your ceiling surface is smooth. Once that's done, now you're going to add the beef. So once you get your ceiling surface done, you can do a test fit with your cover, make sure everything lines up and everything looks like it's going to fit good. The straight edge is going to tell you what you need to know, whether you've taken enough material off. But between the Paper Fel Pro gasket and the RTV, you're going to get a good seal if it's fairly close. You can't have a bunch of porosity and a bunch of imperfections in this face. It's not going to seal if you have it like that. So then, this is actually what I'm doing now, because I've already reinforced it, but I didn't have time to go through all this. So since I'm going to Tennessee here in 2 weeks, I'm not going to want to worry when I'm running the hard trails at Windrock. I'm not going to want to have to worry about this rear end. So I have a 3/16 flat bar. This was 4-inch flat bar, 3/16 thick. You could use 1/4 inch if you want. You can use 1/8 inch if you want, but I think 3/16 is a happy medium. So what you do is you start cutting some pie pieces. They don't have to be exact pie pieces, but they're going to be somewhat pie shaped. You're going to cut some pie pieces like this, and you're going to bend them in the vise. So you're going to put them in the vise, crank them down, hit them with a hammer, and start bending them to conform to this shape. So see, I have a dotted line up here to help reference the area where we're going to be working on. So we're going to go through, I'm probably going to put this one in the middle, and we're going to go through, and we're going to keep our weld back. The most important thing here is not welding anywhere near that face. That face is already set in stone. That face is important. That's our ceiling surface. So all of this reinforcement is going to be held back. Our weld is going to be held back about 3/8 of an inch, and our weld is going to go alongside of that plate. Now, I'm not going to weld all of the plates at once. I'm gonna put each plate on, and I'm gonna weld around the perimeter of this reinforcement plate, and I'm gonna make sure it's, now this one may need tweaked a little, but you're gonna get it to conform to the housing the best you can. Then you're gonna tack it in place, and then you're gonna weld around the perimeter. I want weld around every perimeter of every single one of these pie pieces. I want it to penetrate and go all the way to the metal of the housing. Now remember, preheat to 400, the housing, and then you're using a special nickel rod. And I talk about the nickel rod in my NP205 shave video, where it's the exact same rod that I'm using. I ordered it on Amazon. Nickel 99, I might be mistaken, but that's what's popping into my mind right now, is nickel 99 rod. It's similar to a stainless rod. It's made for welding cast steel, cast iron, and also transition weld from regular carbon steel to any cast material. That's what it's made for, those three things. So I'm gonna weld the perimeter, and then I'll probably clean up the weld and make it more low profile, and then I'll put a pie piece next to it, and then I'll do the same thing until I fill that whole bottom, and I reinforce that whole bottom, and that will be the entire reinforcement for this bottom of this 14 bolt. Not a huge undertaking, but it is a little bit technical, and I wanted to share this with you, and hopefully it'll help you out. But everybody knows the 14 bolt's the best axle out there, one of the best. Gear setup's easy, it's beefy, and there's a lot of aftermarket support. Plus it gives you the pinion support bearing and the option to run a pinion guard, which is huge. So it's kind of a no-brainer. But anyway, guys, I got the first plate on. Now this nickel welding rod doesn't exactly run the best. It doesn't run like 7018. It runs more like stainless. It's very hard to read the puddle, and it is what it is. So anyway, with the preheat on here, start running a fillet weld around the perimeter of each plate piece, and then grind it down so you can slide in the next plate piece next to it, and then you'll put a second pass on it. Once you get the second plate piece on there, you'll obviously do the same thing. You'll weld around the perimeter of it, and if you have any low spots, you can go back and fill them in the end, and get it all above flush. And then once it's all above flush, once it's all welded, you take your tiger paw. Tiger paw is a flap disc, not a flap wheel, but a flap disc. It's called a tiger paw in the welding community, and you smooth it all out. Buff it up and make it look real nice and pretty.